Hello everyone and welcome to the part 2 seminar of Synchronous Reluctance Motor Drive and Their Controls. My name is Don Nguyễn, founder of Power Electric and Motor Drive channel. In this channel we will share with you and we bring you the knowledge about the motor drive control and power electric theory and all the material and the slide presentation and simulation files. So we'll share all it to the community. So this one of a synchronous reluctance machine. So this is the part 2 of this seminar about the synchronous reluctance machine. In part 1, we already looked at the introduction, the working principle, and the motor drive, their advantage and disadvantage of this machine, and some application of that. And now at part 2 of this seminar, we are looking at how to build the motor drive, how to build the speed controller and current controller with the Matlab Simulink environment. And if you have not yet seen my channel, so please visit the link here at my channel. I will show you the link at my channel here. We have various tutorial video about the BLDC motor, about the senseless control of the BLDC drive, about the switch reluctance motor, and some video about the power electric, such as the 3-phase inverter or steering system or the complete project, for example PMSM 100 kilowatts. We share with you all the material and filing.
Okay, what's up everyone? Welcome.
Okay, so you can take a look at my channel. So come back to the presentation today. We will briefly so synchronous reluctance machine is basically an electrical mechanical energy conversion device which can convert the electrical energy to mechanical energy. The last time we looked at the machine principle, which is the reluctance principle, is very important with the machine. And we have some slide of advantage and disadvantage of the motor drive and some application of this motor. And now we are talking about the motor drive, how to control this machine. So in the figure here, you will see the motor, which is our plan to control, and we have the power converter, which is basically supply the voltage and measure to the machine. And the machine is connected by coupling with the mechanical load, and we have the sensor block to measure the voltage, the current of the motor, which is the input of a controller block to supply and generate a full shock to power converter. And we have of course the electrical shock, which is basically the DC shots. For example, we can take from battery or something like that. And then here is a traditional approach to control all the not only the synchronous reluctance machine but also all the 3-phase machine. We have the motor block here, and we have 2 block represent for the controller and limitation, and the other one is the vector control. And we have detail the current controller, which is from Park and Clark transformation. We have the 2 components of the ID and IQ current controller to generate the torque control. And this is block scheme of detailed current controller. We have 2 PI controller for 2 components of ID and IQ. And this is the general block diagram for synchronous reluctance machine. We have 1 block of synchronous motor here, and we have the Park and Clark transformation, and we have the switch controller in the outer group, and the current control in the inner, and we have the current generator with PMSM technique. And the figure 11 detail of rotor speed, variable D and Q current regulator for reverse submersible. Okay, so this is more detail. We have also the SyRM, the inverter, and the speed controller and the current controller inside. Very simple here. Okay, so now why don't we get started with the implement it on the simulation software. So last time we already reviewed the Synchronous motor and the converter block, which is currently supplied with the HE battery here. And now we deep looking development of control block. For control block, we already know that we have the outer loop, which is the speed controller and the current controller in the inside, and we have one block with PMSM generator, and we have finally we have the measure, which measure the current or voltage controller. Okay, so the first one we develop is current controller. So let's see what you can do with the current controller here. You can take the current controller you can check the PMSM current controller here for synchronous reluctance machine, and this block we have the IDIQ reference, IDIQ measurement, VDVQ reference, and refill mark and reset block. So for reset block we have the constant we put at 0 here. And we have this block called the free control. And the first input is the current IDIQ reference, and the second input is the rotor delta omega. Okay, this one we calculate the IDIQ, the pre-control block. We have selector here, and we have two okay. And this one we have 1 and 1. Both side we put 2 in the input both side. Okay. This one also we put 2. Alright, and we have the block product. First one is EDQ and the second one is the omega. we have two pins here. First one is the LD and the second one is the LQ. And we have the mux here. At the output, we have the voltage output. Okay, so we add content here and we change to SyRM. We have Mega here and the IDIQ we take from somewhere. Okay, this is connected with by the PDQ. Okay, and the next one we have the input will be the current and 3-phase. And next one we have the theta. And this one we can easily using the path transformation, using the path lock. Okay, and we have the one selector here. Okay, and this is connected to the EIQ. And the second one, this is the EIQ. Now, this one. And we have the first output. And the final input is voltage, DC voltage. We will divide H, P and R over 3. The BLDC maximum, and we have the reset is 0. Alright, so this is we already rename the current controller here. Okay. And the second one we will manipulate the output controller. This is basically the top controller. So we have two input. In first one is top, and the second one is the current unit. ID and IQ. And we have the top estimation here. We will generate the top from ID and IQ, current, and they must to have the two different ID and IQ, and we multiply them together, and we multiply the ID and subtract of ID and IQ here, and finally we multiply with the torque controller, so the whole of the machine. And we have put the torque. Okay, so I don't want to see the content with you here. The final one, this one is the, and the final one is the PMSM generator. So we can easily take block of 3 parts to level here. And this one we set the BPM, this one we set the FPM, represent for space vector modulation, and this one switching frequency, we can set the switching frequency, and we take the time is the DH. So before that we delete the measuring scope. So the first one we have the BLDC Motor, and the second one is the Omega Motor. First one is the Beta Motor. Final one is the BLDC Motor. And the output we have the first one is the Omega, the second one is BBC, the first one Okay, so we already built the measurement block, which is the 5 inputs. For inputs, which is the current of the 3 phase, the omega and the theta and the voltage measurement, and we have the 5 outputs, which basically is the current, the omega, the theta, and the voltage DC and the predicament enabled. Okay, so I don't want to format content review. Okay, so the input for this is top reference and that's why we connect DNIQ here, and we have the go-to block, which is go-to block here, which is the TQ reference and global here, and we have also the current here, IDQ reference. And same here for the top. and we have from here, and this one should be the derivative. IDT, and we have mod here, also one in BDQ, and this one we will use the inverse of path function. Path function here, and this one can make the data here. Okay, and this one we will choose a Q so here. Okay, and then we have the output of voltage here, 3 phase. Okay, very easy, very easy. And this one we connect the BDC here. Alright, so we already pushed the controller, which is the controller of current controller, and outer loop is the top controller here, and we have the measurement. It generates all the current, the theta, the voltage DC, and finally we have the pull generation for the converter. Okay, so the next one is we generate the amplifier, which is conclude the variant of the BDVCU or the LDAQ resistant here. And I will do it in the next video. I will hope you enjoy watching and learning. And if you like it, please share, like, and subscribe to our channels. So thank you very much for watching. So see you in the next video.